Yeah, welcome to another paper presentation on narrative visualization. This time I want to introduce the paper Augmenting Visualizations with Interactive Data Facts to Facilitate Interpretation and Communication, a paper that appeared in IEEE Visualization in 2018. It is primarily about tabular data, as it occurs quite frequently, with numerical and categorical value, and it helps to automatically detect and describe features such as extremum features or features that characterize the distribution of values or outliers or trends. And this is translated to simple but appropriate natural language processing. So that is meant here with to facilitate interpretation. It's an interesting paper, I can promise you. So that's how this looks. The authors are Arjun Srinivasan, Stephen Drucker, Alex Endert, and John Stasko. So, and as always, the images are taken from the paper that I introduce. I have not written this on every slide, just as a general remark. So here we see already one example of a diagram. For certain districts, we see sales data, and that is commented here with a number of facts, interactive data facts. The total sales are commented, the distribution ranges from to, so that means minimum and maximum is explained here. Also the difference is explained, that means the range of the values. The average is also commented, and the median. I have a little doubt whether in a broad audience people are familiar with a median, but yeah, nevertheless, it may be useful to comment it. Sales is relatively evenly distributed across all the districts. That is also commented based on this automatic analysis, and it is finally commented on some districts that represent a particularly high portion of the scales. So I first want to introduce interactive data facts based on the paper. Then they are categorized and used for interpretation. I will also show what they call alternative visualizations. So basically, when the user of the tools that the authors present here, that's called VODA, the users of this VODA tool can specify the type of visualization that they want to create, and then get a list of alternative visualizations to further facilitate this authoring process. Yeah, so the paper presents techniques and a tool. I mentioned already the name, VODA, to support the extraction of data facts from tabular data. Yeah, so and these data facts are natural language statements as we have seen them on the last slide. And basically they are derived from simple descriptive statistics. Yeah, and to already say a few words on the categorization. There are mainly three types of data facts. I used three different colors here in order to convey this: extremum related facts, distribution related facts, and correlation based related facts. Yeah, and here you see a couple of examples for each of the three categories. So correlation related facts are often commented with the word associated. Something is associated with something else. Yeah. So by the way, the examples here are to some extent my examples. It was easy for me to understand what they mean and to relate this to data with a health background. You know, that's what I'm particularly interested in. Yeah, so this paper already had previous work on which it could build. Data facts were extracted by so-called auto-insight tools. So insights should be automatically computed. And one example is Microsoft Business Intelligence. And there's also data mining work where, for example, the top K insights of tabular data are automatically extracted. So then there is still the task to translate this to natural language, but this gives you the most important facts according to some interestingness measure. For example, stronger correlations are more important than weaker correlations, so that could be used here as a criterion for automatically extracting insights. There was also previous work on how to efficiently compute insights from large data, what I really can say also from our own experience, where we analyzed large epidemiological data. If you want to exhaustively find, for example, correlations of a certain type and strength, that is really something that involves a lot of computational effort. In our experience, we needed to parallelize this, so we used 64 computers in parallel. We also employed GPU computing, so that is something where efficiency really is important. And yeah, here is also other work mentioned on efficient computation of insights. That runs as a background process, so that means they create a kind of news feed in this paper here. Whenever they found a new insight that appears like in the news feed from Facebook or others. The expressions are created with natural language generation systems based on templates. Yeah? So this is predefined text with a certain structure where there are some variables, and the variables are instantiated according to the current data fact. Yeah? And these templates serve to communicate the facts. So a related work discussion in a paper, on the one hand, has to describe what was already there, and on the other hand, of course, they also have to describe research gap. Otherwise, there would be no motivation for their own work. And the research gap that was described here is it is difficult if there are many data facts to communicate them. And the solution strategy that the authors here envision is to categorize the data facts according to their priority. Yeah? So to determine which facts are more important than others. So if you have to restrict yourself, for example, because of space reasons, yeah, there is enough space to comment on 10 data facts, this should help to find the 10 most important ones. Then the relation between a data fact and the visualization with previous tools was difficult to see. Yeah? Ideally, I read a data fact and can immediately perceive to which part of the visualization this refers. Yeah? The bar in a bar chart, for example, that is commented by a data chart. So what is needed here is a kind of highlighting, yeah, and that ideally is dynamic. So whenever I select, for example, a data fact, I see corresponding parts of the visualization emphasized, or vice versa. Yeah, so that could be a bidirectional thing. Yeah, and there are in principle different ways to visualize data and to see the data facts, and yeah, automatically it would be difficult to decide which one is the best. Ideally, the authors have the option to choose among a few alternative visualizations. Yeah? So the overall strategy was not to do everything in a fully automatic manner, but more in a mixed initiative manner, or in previous times I would have said in a semi-automatic manner, where automatic computation and interactive selection is carefully combined. So here's an example of visualization and related data facts, or even a couple of examples. Yeah? The visualizations that you recognize here are scatter plots with grids that help a bit to read the specific numbers. Here we see a donut chart, a bar chart, and another kind of scatter plot. Yeah? They all have a title. Something is mentioned as I would say this is a subtitle, yeah, by date or by category. And then, for example, a correlation is commented. Yeah, this here is about defects, downtimes in minutes, and total defects in a certain range. Yeah, so here is a correlation commented, here is the majority commented, so the one entry in this donut chart that occupies more than half of the space. Packaging accounts for the majority of defect type for hardware, so when do the defects occur? Then it is displayed here how the defects distribute over different countries, with the US clearly leading before Japan and Europe. And this one here probably belongs to another data set. I think that's the car data set, where the displacement and miles per gallon, that's the consumption or the inverse consumption is commented. And yeah, again, a kind of correlation-based fact is computed. For every increase of 10 in miles per gallon, displacement decreases by about 108. Yeah, by about. So this expression, I think, is quite appropriate to indicate that there is a correlation that is not very strong. Yeah, so facts are prioritized. That's the basic idea to cope with a large number of facts. They said we have so-called tier 1 facts. These are extremum values, yeah, the highest and lowest one, or the majority, as we have seen in the donut chart. Medical example could be stroke accounts for the majority of disabilities. And then there are tier 2 facts that are a little less important. So for example, the second highest value or the second lowest value. And tier 3 facts are the remaining data facts. Yeah, so only if there is space or time available, you would also comment or display the tier 3 facts. So I mentioned already 3 types of data facts: extremum related, distribution related, and correlation related facts. Here I go a little bit more into detail what this means. And then there's one further data fact, and these are outliers. Yeah. On the first glance, one may think that an outlier is basically the same like an extremum related facts. That is possible, but it is not necessarily the case. Yeah, imagine in a scatter plot that shows a quite good correlation between 2 variables. There could be an outlier that is just far away from this line where most of the values are lying. That does not mean that this outlier has to have an extremum value in x or y dimension. Yeah, but it is just far away from others in 2-dimensional or high-dimensional space. Yeah, so I think the extremum related facts are clear. Distribution related facts include, for example, the interquartile range. That means the range where 25% of the values are below and 25 are above. So 50% of the values are within this range. Median and standard deviation are also mentioned. I said already that I have a little doubt that a broad audience understands a median very good, and I would say the same doubts I have with respect to the standard deviation. One thing that the authors have not mentioned here, that's what I added, is peaks. Yeah, if I have a certain distribution, this may be a distribution with one peak, yeah, like the Gaussian curve, but it could be also something with several peaks, yeah, 2 or even more peaks. So then the number of peaks could be interesting. That's often called a multimodal histogram. Or it could be interesting how far these peaks are away from each other. Another distribution-related fact that I sometimes see is there may be even a gap in the data. That means we have values in this range, and then there's a gap, and here we have again values in another range. Yeah. So if such a gap would exist, that is something that would also fall in this category of distribution-related facts. Yeah, correlation-related facts obviously refer to a certain type of correlation, and I want to really emphasize that there is more than linear correlation. Maybe that's, again, based on my background with medical data. There we often have quadratic correlations, sometimes also logarithmic correlations, so there could be more. The type of correlation is interesting and the strength of correlation. Yeah, I like these terms here. The extremum-related facts, that is something that the authors refer to as point insights, whereas the distribution-related facts are categorized as, or characterized is maybe better, as shape insights. Yeah. So here I think of the histogram, which is a very good visual representation of a distribution, and then indeed we have a certain shape. Yeah. And the correlation-related facts are referred to as trends. Yeah. And that's also something I see quite frequently in other papers on narrative visualization. Terms that I've, or things that I would see in other papers in visual analytics described as correlation in narrative visualization are often characterized as trends or as trend lines. So that's, yeah, probably a quite appropriate term in this context. Yeah, and then there are, of course, different ways to visualize the data and to see the data facts. Yeah, we have already seen different chart types that can be used to convey a distribution. A donut chart is primarily useful for categorical data, and when the number of categories is not so large. Histograms are more for numerical data. Stripe plots would be an alternative. So that's the basic chart type, and maybe the first decision that an author has to do. The second one would be the embellishments. That means what should be labels, for example, or whether there are quadrant lines in a scatter plot. Yeah. So embellishments include things that in other papers are characterized as annotation. Yeah. That was in my previous paper presentation video. Labeling definitely is a kind of annotation, and also the creation of hulls or other shapes to reveal a certain set of points like a cluster. That's a kind of graphical annotation. Data may be shown as raw data. That means without any kind of aggregation. But of course, binning, for example, could be used in order to show the data in a more aggregated manner. And that depends on the size and complexity of the data, whether it is feasible to show the raw data without overwhelming the user, or whether some kind of aggregation is necessary. Yeah. And then there are mappings between data facts and visualization. With this, I refer to the problem that the authors have identified in previous work, that the relation should be clear between a data fact and parts of the visualization to which it refers, for example, by using the same color. Yeah, this is a screenshot here from this Voder tool, a manual view specification. So cylinders and displacement, and in particular the average values, should be mapped here to the x and y coordinates of a scatter plot based representation. And as a mark type, a box should be used. And then one may ask for possible visualizations. Yeah, that is shown here. A number of different visualizations for these data are suggested. Yeah, as a kind of recommendation, one may also say. It's not just one recommendation, but a couple of feasible visualizations. Yeah, a little bit discussion about limitations and also an outlook. The system is restricted to the automatic generation of data facts. Yeah, one could think about extending this, and in fact the authors discussed this idea, that the user may also add facts and relate them to the visualization. So here, if the system does not determine a certain fact, there is no way to bring it in the system. And of course, there are good reasons why a user may identify a valid data fact that the system has not automatically determined. The data facts are restricted to simple descriptive statistics. That means nothing like clustering or search for association rules or outlier detection is incorporated here. Yeah, one may imagine more full-fledged visual analytics systems that is able, by means of these machine learning techniques, to identify further data facts and comment them, and that may enable deeper insights. The data is also restricted to one data set, and this data set consists of categorical or numerical variables. Yeah? One could think of extending this towards data sets at different points in time. Yeah? So, for example, we want to automatically convey differences in the sales data between the previous year and the current year, and maybe we have simulated or predicted outlook for the next year as well. Yeah, the data that was used here was rather small. We have seen this in the example, in the examples. In real life, you often have more dimensions and more items, so the tables are just much larger. And then probably other strategies could be useful. I mentioned from previous work one idea that in a background process many facts are identified and shown in a kind of news feed, yeah, that resembles a little bit to this idea of progressive analytic as well. Yeah, and I already commented on the number of strategies that may be useful for really analyzing larger data sets. Yeah, so for an authoring tool, that's the take-home message here. Data facts and insights may be automatically computed. We have seen this here for the example of tabular data. Tabular data is an important example. It might certainly be extended to other kinds of data as well. Yeah, so for example, spatial data or spatial temporal data. The insights may be translated in natural language based on rather simple templates. Yeah? So if you want to do something like this yourself, you need not to have a full course on natural language generation because the kind of expressions that are generated here are quite small. The interpretation of the insights requires cognitive load, yeah, and therefore dynamic emphasis is useful and needed. Yeah, so I thought about this again with respect to some medical applications. In particular in epidemiology, large data sets are collected. Data is acquired in a very standardized manner with respect to lifestyle, health disorders, and so on. And in a similar way, like described here, one could try to automatically identify important data facts that better characterize risk factors and their relation to health disorders. Yeah? So these are correlation or association facts, but also distribution facts are interesting. For example, to understand what is indeed a range of normal values for a certain laboratory parameter, for example. I want to also use one part of the paper for my presentation here that I found quite interesting. Namely, they compared exploratory visualization for an expert compared to narrative visualization. Yeah? For exploratory visualization, it is really clear that the expert needs also support to take notes, to express what she found. Bookmarking may be interesting. So in addition to the data that is available, new data or new content is generated by the expert using the system. And another aspect of exploratory visualization is the expert may be supported in the process of generating a report based on selected visualizations and annotation. That is quite frequently done in medicine, in radiology, yeah, where a radiologist not only has to find in his head the right diagnosis for the patient, but he has to clearly describe this using appropriate images and to convey this to others. And this process is time consuming, and there is considerable support meanwhile in a radiology workstation for this process. And in a similar way, an engineer, for example, carrying out large simulations of different variants of an engine can be supported in generating a report related to the findings. In narrative visualization, typically we have no user-generated content. Yeah? The casual user of such a system is not supposed to take notes or bookmark something or to create a report as something to take home. Yeah? So this leads to some research questions, namely, is there a demand for note-taking and reporting in narrative settings, or maybe in some specific narrative settings? And if so, of course, how it can be realized and in which settings. Probably not exactly in the same way as it is done in systems developed for experts. Yeah, so differences to note-taking in exploration and narrative visualization could be interesting if it turns out that note-taking is also useful in certain situations in narrative visualization. Yeah, finally, as usual, the look at the references. I introduced this bold displayed paper here, Augmenting Visualizations with Interactive Data Facts to Facilitate Interpretation and Computation. It is based on, I would say, primarily two previous papers or related papers. Data side proactive visual data exploration with computation of insight-based recommendation. It's from Kui et al. And from Tang et al. Extracting top K insights from multidimensional data that was presented as a leading machine learning conference. Yeah, with this, I want to thank you for your attention.